Chapter 1 Review. Key terms. Algebraic expression. Constants and variables combined using addition, subtraction, multiplication, and division. Associative property of addition. The sum of three numbers may be grouped differently without affecting the result. In symbols. A plus, open parenthesis, B plus C, closed parenthesis, equals, open parenthesis, A plus B, closed parenthesis, plus C. Associative property of multiplication. The product of three numbers may be grouped differently without affecting the result. In symbols. A dot, open parenthesis, B dot, C, closed parenthesis, equals, open parenthesis, A dot, B, closed parenthesis, dot, C. Base. In exponential notation, the expression that is being multiplied. Binomial. A polynomial containing two terms. Coefficient. Any real number, a sub I, in a polynomial in the form a sub n, x to the power of n, plus dot, 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 plus a sub 2, x to the power of 2, plus a sub 1, x to the power of 1, plus a sub 0. Commutative property of addition. Two numbers may be added in either order without affecting the result. In symbols. A plus B equals B plus A. Commutative property of multiplication. Two numbers may be multiplied in any order without affecting the result. In symbols. A dot B equals B dot A. Constant. A quantity that does not change value. Degree. The highest power of the variable that occurs in a polynomial. Difference of squares. The binomial that results when a binomial is multiplied by a binomial with the same terms, but the opposite sign. Distributive property. The product of a factor times a sum is the sum of the factor times each term in the sum. In symbols. A dot, open parenthesis, B plus C, closed parenthesis, equals A dot, B plus A dot, C. Equation. A mathematical statement indicating that two expressions are equal. Exponent. In exponential notation, the raised number or variable that indicates how many times the base is being multiplied. Exponential notation. A shorthand method of writing products of the same factor. Factor by grouping. A method for factoring a trinomial in the form a x squared plus bx plus c. By dividing the x term into the sum of two terms, factoring each portion of the expression separately, and then factoring out the GCF of the entire expression. Formula. An equation expressing a relationship between constant and variable quantities. Greatest common factor. The largest polynomial that divides evenly into each polynomial. Identity property of addition. There is a unique number, called the additive identity, 0, which, when added to a number, results in the original number. In symbols. A plus 0 equals A. Identity property of multiplication. There is a unique number, called the multiplicative identity, 1, which, when multiplied by a number, results in the original number. In symbols. A dot 1 equals A. Index. The number above the radical sign indicating the nth root. Integers. The set consisting of the natural numbers, their opposites, and 0, dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Inverse property of addition. For every real number a, there is a unique number, called the additive inverse, or opposite, denoted -a, which, when added to the original number, results in the additive identity, 0. In symbols. A plus, open parenthesis, -a, closed parenthesis, equals 0. Inverse property of multiplication. For every non-zero real number a, there is a unique number, called the multiplicative inverse, or reciprocal, denoted 1 over a, which, when multiplied by the original number, results in the multiplicative identity, 1. In symbols, a, dot, 1, over, a, equals, 1. Irrational numbers. The set of all numbers that are not rational. They cannot be written as either a terminating or repeating decimal. They cannot be expressed as a fraction of two integers. Leading coefficient. The coefficient of the leading term. Leading term. The term containing the highest degree. Least common denominator. The smallest multiple that two denominators have in common. Monomial. A polynomial containing one term. Natural numbers. The set of counting numbers. 1, 2, 3, dot, dot, dot. Order of operations. A set of rules governing how mathematical expressions are to be evaluated, assigning priorities to operations. Perfect square trinomial. The trinomial that results when a binomial is squared. Polynomial. A sum of terms each consisting of a variable raised to a non-negative integer power. Principal nth root. The number with the same sign as a, that when raised to the nth power, equals a. Principal square root. The non-negative square root of a number, a, that, when multiplied by itself, equals a. Radical. The symbol used to indicate a root. Radical expression. An expression containing a radical symbol. Radicand. The number under the radical symbol. Rational expression. The quotient of two polynomial expressions. Rational numbers. The set of all numbers of the form m over n, where m and n are integers and n is not equal to 0. Any rational number may be written as a fraction or a terminating or repeating decimal. Real number line. A horizontal line used to represent the real numbers. An arbitrary fixed point is chosen to represent 0. Positive numbers lie to the right of 0, and negative numbers to the left. Real numbers. The sets of rational numbers and irrational numbers taken together. Scientific notation. A shorthand notation for writing very large or very small numbers in the form a multiplied by 10 to the power of n, where 1 is less than or equal to the absolute value of a is less than 10, and n is an integer. Term of a polynomial. Any a sub I x to the power of I of a polynomial in the form a sub n x to the power of n plus dot 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 plus a sub 2 x to the power of 2 plus a sub 1 x to the power of 1 plus a sub 0. Trinomial. A polynomial containing three terms. Variable. A quantity that may change value. Whole numbers. The set consisting of 0 plus the natural numbers 0, 1, 2, 3, dot, dot, dot. Key equations. Rules of exponents. For non-zero real numbers, a and b and integers, m and n. Product rule. A to the power of m dot a to the power of n equals a to the power of m plus n. Quotient rule. A to the power of m over a to the power of n equals a to the power of m minus n. Power rule. Open parenthesis, a to the power of m, closed parenthesis, to the power of n, equals a to the power of m dot n. Zero exponent rule. A to the power of 0 equals 1. Negative rule. A to the power of negative n equals 1 over a to the power of n. Power of a product rule. open parenthesis, a, dot, b, closed parenthesis, all to the power of n, equals, a, to the power of n, dot, b to the power of n. Power of a quotient rule. Open parenthesis, a, over, b, closed parenthesis, all to the power of n, equals, a, to the power of n, over, b to the power of n. Perfect square trinomial. Open parenthesis, x, plus a, closed parenthesis, all squared, equals, open parenthesis, x, plus a, closed parenthesis, multiplied by, open parenthesis, x, plus a, closed parenthesis, equals, x squared, plus 2, a, x, plus a, squared. Difference of squares. Open parenthesis, a, plus b, closed parenthesis, multiplied by, open parenthesis, a, minus, b, closed parenthesis, equals, a, squared, minus, b squared. Difference of squares. A, squared, minus, b squared, equals, open parenthesis, a, plus b, closed parenthesis, multiplied by, open parenthesis, a, minus, b, closed parenthesis. Perfect square trinomial. A, squared, plus 2, a, b, plus b squared, equals, open parenthesis, a, plus b, closed parenthesis, all squared. Sum of cubes. A, cubed, plus b cubed, equals, open parenthesis, a, plus b, closed parenthesis, multiplied by, open parenthesis, a, squared, minus, a, b, plus b squared, closed parenthesis. Difference of cubes. A, cubed, minus, b cubed, equals, open parenthesis, a, minus, b, closed parenthesis, multiplied by, open parenthesis, a, squared, plus a, b, plus b squared, closed parenthesis. Key concepts. 1.1. Real numbers. Algebra essentials. 1.1.1. Rational numbers may be written as fractions or terminating or repeating decimals. See Example 1 and Example 2. 1.1.2. Determine whether a number is rational or irrational by writing it as a decimal. See Example 3. 1.1.3. The rational numbers and irrational numbers make up the set of real numbers. See Example 4. A number can be classified as natural, whole, integer, rational, or irrational. See Example 5. 1.1.4. The order of operations is used to evaluate expressions. See Example 6. 1.1.5. The real numbers under the operations of addition and multiplication obey basic rules, known as the properties of real numbers. These are the commutative properties, the associative properties, the distributive property, the identity properties, and the inverse properties. See Example 7. 1.1.6. Algebraic expressions are composed of constants and variables that are combined using addition, subtraction, multiplication, and division. See Example 8. They take on a numerical value when evaluated by replacing variables with constants. See Example 9, Example 10, and Example 12. 1.1.7. Formulas are equations in which one quantity is represented in terms of other quantities. They may be simplified or evaluated as any mathematical expression. See Example 11 and Example 13. 1.2. Exponents and scientific notation. 1.2.1. Products of exponential expressions with the same base can be simplified by adding exponents. See Example 1. 1.2.2. Quotients of exponential expressions with the same base can be simplified by subtracting exponents. See Example 2. 1.2.3. Powers of exponential expressions with the same base can be simplified by multiplying exponents. See Example 3. 1.2.4. An expression with exponent 0 is defined as 1. See Example 4. 1.2.5. An expression with a negative exponent is defined as a reciprocal. See example 5 and example 6. 1.2.6. The power of a product of factors is the same as the product of the powers of the same factors. See example 7. 1.2.7. The power of a quotient of factors is the same as the quotient of the powers of the same factors. See example 8. 1.2.8. The rules for exponential expressions can be combined to simplify more complicated expressions. See example 9. 1.2.9. Scientific notation uses powers of 10 to simplify very large or very small numbers. See example 10 and example 11. 1, 2, 10. Scientific notation may be used to simplify calculations with very large or very small numbers. See example 12 and example 13. 1.3. Radicals and rational exponents. 1.3.1. The principal square root of a number, a, is the non-negative number that, when multiplied by itself, equals a. See example 1. 1.3.2. If a and b are non-negative, the square root of the product a dot b is equal to the product of the square roots of a and b. See example 2 and example 3. 1.3.3. If a and b are non-negative, the square root of the quotient a over b is equal to the quotient of the square roots of a and b. See example 4 and example 5. 1.3.4. We can add and subtract radical expressions if they have the same radicand and the same index. See example 6 and example 7. 1.3.5. Radical expressions written in simplest form do not contain a radical in the denominator. To eliminate the square root radical from the denominator, multiply both the numerator and the denominator by the conjugate of the denominator. See example 8 and example 9. 1.3.6. The principal nth root of a is the number with the same sign as a, that when raised to the nth power, equals a. These roots have the same properties as square roots. See example 10. 1.3.7. Radicals can be rewritten as rational exponents and rational exponents can be rewritten as radicals. See example 11 and example 12. 1.3.8. The properties of exponents apply to rational exponents. See example 13. 1.4. Polynomials. 1.4.1. A polynomial is a sum of terms each consisting of a variable raised to a non-negative integer power. The degree is the highest power of the variable that occurs in the polynomial. The leading term is the term containing the highest degree, and the leading coefficient is the coefficient of that term. See example 1. 1.4.2. We can add and subtract polynomials by combining like terms. See example 2 and example 3. 1.4.3. To multiply polynomials, use the distributive property to multiply each term in the first polynomial by each term in the second. Then add the products. See example 4. 1.4.4. FOIL. First, outer, inner, last, is a shortcut that can be used to multiply binomials. See example 5. 1.4.5. Perfect square trinomials and difference of squares are special products. See example 6 and example 7. 1.4.6. Follow the same rules to work with polynomials containing several variables. See example 8. 1.5. Factoring polynomials. 1.5.1. The greatest common factor, or GCF, can be factored out of a polynomial. Checking for a GCF should be the first step in any factoring problem. See example 1. 1.5.2. Trinomials with leading coefficient 1 can be factored by finding numbers that have a product of the third term and a sum of the second term. See example 2. 1.5.3. Trinomials can be factored using a process called factoring by grouping. See example 3. 1.5.4. Perfect square trinomials and the difference of squares are special products and can be factored using equations. See example 4 and example 5. 1.5.5. The sum of cubes and the difference of cubes can be factored using equations. See example 6 and example 7. 1.5.6. Polynomials containing fractional and negative exponents can be factored by pulling out a GCF. See example 8. 1.6. Rational expressions. 1.6.1. Rational expressions can be simplified by canceling common factors in the numerator and denominator. See example 1. 1.6.2. We can multiply rational expressions by multiplying the numerators and multiplying the denominators. See example 2. 1.6.3. To divide rational expressions, multiply by the reciprocal of the second expression. See example 3. 1.6.4. Adding or subtracting rational expressions requires finding a common denominator. See example 4 and example 5. 1.6.5. Complex rational expressions have fractions in the numerator or the denominator. These expressions can be simplified. See example 6.